Hi, my name is James Fitzpatrick, and this is an introduction into my IOT Smart Lights. It is an assessment for a college project. In the project, there is 4 main aspects to it. We have one light device, and we have a second light device. We have a web page, and we have a chat application. In these 6 windows, I have the terminal outputs of all the different applications that's used. This window is the first Raspberry Pi with the breadboard and LEDs. This terminal window is a testing application of static lights, just mocked up lights. This window is the terminal output of the second Raspberry Pi, which has a scent hat on top. This window is allowing us to interact with the MQTT broker directly. This terminal window is giving the output from the chatbot, and this terminal window gives the output from the web application. I will start the test application in interactive mode. This is in interactive mode, and these are messages it's after publishing, and what kind of message it was an update status message. If we do DIR, we can see the device. We can see a device and lights, remote lights and switches that have been saved out for ease. What we can do is we can go switch 1 and call the function on. It sends out a message, and it has turned on light 5 and light 6. Both are saying they're now on. So if we do switch 1, that off, now both lights are off. If we start the broker in interactive mode, we can get it to request its information. This sends out a blank message to all devices asking for information. As you may have seen, this device had some interaction, and now if we pretty print the payload that's in the broker, it gives us a list of the lights, the actions, their names and their status. So if we go back here now and we turn back on the S1 light, we get that light 5 and 6 are on, and over here if we pretty print that, we get only that light 6 is on. This is due to a bug in the manner in which the status message is updated. Each light publishes their own status message, and depending on timing, this can override status of other lights. This causes a fatal flaw when trying to turn off all lights using the chatbot. I'll now start the chatbot running. As you see, once again, there's activity on our virtual device. If we switch to chat application, we can add the chatbot to our conversation, and we have to start it, which we get greeted by a welcome message. The chatbot has certain commands that we can issue. This is giving us the status of all the lights, and here it is telling us that light 5 was turned on. So if we recheck our payload here, it does say that light 5 was turned on. There is a timing issue with these. So back here now we can go and we can turn off light 5. And here we now get a message saying that light 5 has been turned off. If we check what's in the broker, it is saying that light 5 is off. We can also turn on any of the lights from the chatbot, and now it says that light 7 is on. I am now going to start the Raspberry Pi that's connected to the breadboard. One of the issues that I have, the status message that's sent out, it's too chatty. There's too much information being sent out at once. Once one device does something, it gets the message actions get compounded as time goes on. The more devices in the network, the worse the traffic becomes. If we now look at our payload, we now see that we have a green light and a yellow light. If we look at the lights in the chatbot, we now also have a green light and a yellow light. We can turn on the green light, just turn down here, or we can turn off the green light again. With the green light being on, you can use the physical switches on the device to turn them off. There is an issue where it sometimes needs a double throw to get it to work. I have not been at this time being able to track down what's causing this bug issue. So as you can see, the light is on, and when I flick the switch it should be turned off, but it doesn't. But now when I flick the switch for the second time, the light does go off. As you can see, it's saying that all lights are switched off. And now the yellow light is switched on. Back in the application, it's showing just information of which switches have been flipped on which pins on the board, and which lights are after doing stuff. If we now look at the status, we can see that the payload is saying that the yellow light is switched on. I'll now start the Raspberry Pi with the Sense hat attached to it. The green light was just to show that it was activating, and you can see up on top how there's several communications after taking place. If we look at the payload that's in the broker now, we see that we now have a sense grid and its status is false, so this is turned off. The button on the sense hat can be used to switch on and off the grid. Third switch on the Pi should switch that on, but I'm not sure where the issue is. Sometimes when you're working with SenseHat, the grid doesn't work as expected. It sometimes will close by just turning off the lights row by row by row, and this could take some time. While that's just resting, because it could actually turn that grid on at some stage later on after flicking that switch now. I don't believe it will, but it could. In the chatbot, you can now see the sense grid is there too, and this is saying it's turned on, which leads me to believe that it will eventually turn the light on. So I'm not sure where the issue is. And here it's saying that that light is turned on. If we start the web server, you can see that everything is communicating with everything else. There's lots of traffic messages being sent around. This would not be ideal. The status messages needs to be updated some manner. There needs to be a better way of sending this information around to each other. While they're doing its thing, if we go back here now, we refresh the web page, we can see which lights are on and off. One problem, when you interact with the lights, they don't automatically refresh the page. So when I click the green light on, we get a message asking us to wait for the green light to be turned on. If we now look at the payload, we can see that the green light and the yellow light are both switched on, which on the physical device they are switched on. We can also see that the virtual light L6 is also switched on. When we look at the web page for these now, we will just refresh, we can see that these lights are switched on. If we turn off the green light, we get a pop-up message saying that this light is being turned off. We can see in the physical world that that light turned off pretty much straight away. Unfortunately, we need to refresh the page to see that this light has been turned off. I'm now going to try interact with the sense grid using the web page. The sense grid doesn't seem to work as well as the physical lights attached to the board. As you can see, I got the message saying it was turned on. We refresh the page, it's still saying the message that the grid is off. In the physical world, the grid is off. Thank you for watching my short video introducing my IoT Smart Lights.